Hey subscribers, welcome back. This video is looking at the lowest common multiple. We're going to start off with a quick example here. So here's an example of a question where we need to use the lowest common multiple. So Mr. Pullman runs a lap of the park in 7 minutes. Mr. V runs a lap of the park in 4 minutes. If they start at the same time, when do they meet at the start line again? So have a go with this first and decide when are they going to meet again at the start line. We're assuming that they run fixed times, so they're not slowing down or speeding up, and they're continuing to run. Okay, so hopefully you've had a go with this. I have a nice representation of this so we can visualize what's happening. So here's an example of, you can consider it to be a number line, but also in this case it's a timeline as well. So you can see they both start at 0 minutes. So they're obviously at the start line together. That's the first time that they meet. And then after 4 minutes, Mr. V is at the start line again. So he's done one lap. And then at 7 minutes, Mr. Pullman's done his lap, and Mr. V's a minute later finished his second lap. And as this keeps going, you can see that Mr. V follows these times to the start line, and we're assuming they just keep on running. So after 28, you're going to get 32 minutes, and then it just keeps going. And in case of Mr. Pullman, you get 7 times tables. You get 7, 14, 21, 28. And again, that also keeps going. But the thing you may have noticed here is the fact that 28 is common to both. And that's basically what lowest common multiple is. These are multiples of 4, multiples of 7. We want the lowest number that's common to both, excluding the 0. Because we're actually going to, the first time that these two runners meet is at 28 minutes. So lowest common multiple is about listing the multiples and finding the first common multiple for both the 4 and both the 4 and the 7 times tables. You might ask yourself, do they meet ever again? Well, there will be another time, and it's going to be in another 28 minutes. So every 28 minutes they meet each other. So 28 plus 28 is 56 minutes, and then again plus 28 gets you to 84 minutes, and it keeps going for as long as they're running. Now we've made a few assumptions here that again they don't slow down or speed up, and they cross the line at the same pace every time. So this is what a lowest common multiple question might look like, except instead of running laps around the park, it might be something that's repeated. So it might be buses arriving or leaving every 5 minutes, every 7 minutes. It could be referring to traffic lights that go green every 10 minutes or every 3 minutes, and when are they going to match up and both be green at the same time, and so on. So before we look at some examples of how to work out lowest common multiple without doing a whole timeline or a number line, I want you to just be familiar with this definition. So a coprime, a pair or more of numbers which are coprime, have the highest common factor as 1. So let's have a look at what that means. For 2 and 3, what numbers fit into 2 and 3? Well, they happen to both be prime numbers here. So actually the highest common factor is 1. So these numbers are coprime. Now you're going to need to know about coprime numbers for the next part of this video when we look at lowest common multiple. So how about 10 and 15? Well, we know 1 is a factor, but there's another obvious factor here, which is 5 as well. So the highest common factor is not 1, it happens to be 5. So in this case, they are not coprime. Have a go with the rest of the numbers and decide whether they're coprime or not, and then I'm going to go through these with you. Okay, so for the next question, we can see, well, there's a factor other than 1, which is 5, so these are not coprime. There may be other factors, but we just need to know that there's another factor other than 1, and it automatically. 6 and 32, well, 2 goes into both as well as 1, so these are not coprime. 2, 3, and 5. Now it doesn't have to just be numbers which are in pairs. It could be threes. Now 2, 3, and 5. The highest common factor of all three numbers is going to be 1. So in this case, we can say that these are coprime. Two, 3, and 6. Well, the highest common factor of these three numbers for all three is actually still 1, because although we can divide the 3 and 6 by 3, you can't divide the 2 by 3, so these are coprime. And then for 10 and 11, these are also coprime. Okay, so now we know what coprime numbers are, we're ready to look at lowest common multiple. So here's an example of finding the lowest common multiple of 10 and 15. So method 1 is the old way that you might be used to doing, which is just to make a list. So what's the lowest common multiple of 15 and 10? You can refer this back to the example before. Let's pretend one person does the lap every 15 minutes, one person does a lap every 10 minutes. When are they going to match up again? Or you can think of this as a light that flashes every 15 seconds and another light that flashes every 10 seconds. When do they flash together? So for the first bit, let's do method 1, which is listing. So we could write 10, the next flash is at 20, 30, 40, and it keeps going. In the other case of 15, we're going to write the 15 times table, so 15, 30, 45, and so on. You may have spotted already that 30 is common to both. So the lowest common multiple of 10 and 15 is 30. Now, the second method is going to be new to you. It's kind of a variation of the upside down bus stop method, except this time we're going to put two numbers in, 15 and 10. Now you're used to prime factor decomposition. This is different because we don't have to use prime numbers. We will in this case, but we don't have to. Any number that goes into both will work. So in this case, I know that 5 fits into 15 and 10. So you find a number that goes into both. So 15 divided by 5 is 3. 10 divided by 5 is 2. Now, these two numbers are coprime. So we stop. And now we're going to look at how to spot the lowest common multiple. How can we make 30 with the numbers that we have? So you may have spotted that it's going to be this L shape here. So lowest common multiple, think of the L shape. It's 5 times 3 times 2. 5 times 3 is 15, 15 times 2 is 30. The lowest common multiple is 30. Now we're going to do a couple more questions using both the listing method and the upside down bus stop method. So here's an example of 30 and 45. Actually, we're just going to use the upside down bus stop method. That's what we're going to practice using because that's the main method we're going to use. So 30 and 45. Find a number that divides into both and then keep dividing down. I'm going to show you I'm going to finish this example in a few seconds. So if you pause the video and have a go first, and then I can show you how to do it. Okay, so I'm now going to have a go. So we're going to divide this by 5. So 30 divided by 5 is 6. 45 divided by 5 is 9. I'm going to draw upside down bus stop. Now, is there a number that goes into both of these other than 1? Yes. So they're not coprime because we can divide them by 3. So 6 divided by 3 is 2. 9 divided by 3 is 3. Now here, they're coprime. So we just write coprime here. That means we stop, and then we have to highlight the L shape. Remember, because it's lowest common multiple, it's L shape, so you can see there's the L. And then we're going to work out what this multiplies to. So 5 times 3 times 2 times 3. So 5 times 3 is 15, 2 times 3 is 6, and then 15 times 6, so that's going to be 90. So the LCM of 30 and 45 is 90. Right, have a go with the second example, pause the video, and then I'm going to show you how to do this as well. Okay, so we're going to write the two numbers here, 10 and 12. Now I can divide them both by 2 to get 5 and 6. Now 5 and 6 are co-prime, because there's nothing that divides both of them other than 1. So we stop here and then we draw the L shape and we multiply these out. So this is going to be 2 times 5 times 6, which is 10 times 6, which is 60. So the lowest common multiple of 10 and 12 is 60. Okay, have a go with these 5 questions as a quick check. Check your answers here as you get your answers, and then there's an exercise coming up. Now I'm going to do a couple of these examples. If you don't need them, if you got these questions right, you can skip ahead to the exercise just a bit later on in the video after this slide. So I'm going to just randomly pick one. I'm going to pick D, so for 9 and 60. So 9 and 60. So I'm going to divide this by 3 to get 3. 60 divided by 3 is 20. Now 3 and 20 are co-prime. So we're going to now multiply these numbers. 3 times 3 times 20. So that's 9 times 20, which is 180. So that's just an example of question D. The rest follow the same idea as well. So here's the exercise for you to try. Try all of these questions, copy out the questions, have a go, and then I'm going to show you the answers. Pause the video, and here come the answers in 3, 2, 1. So the first part of the answers are here, mark your work. And then the second part is here for you. So check your working, check your answers, and we'll finish with a quick question, problem solving question. Okay, so here's a problem solving question. Pause the video and have a go, and then I'm going to go through it with you. Alright, so buses leave Ashby station every 24 minutes, and buses to Barford leave every 20 minutes. If the first bus leaves at 7:30, when will they next leave the bus station at the same time? Okay, so essentially what we want to do is work out the lowest common multiple of 24 and 20. And then we need to add this time to 7:30, because 7:30 is when they meet first. So let's work this out. So we can divide both of these by 2 to get 12 and 10. We can divide both of these by 2 again to get 6 and 5. And then we've got our co-prime numbers. So these are co-prime, so we stop. And then we multiply these out. So 2 times 2 times 6 times 5. So this becomes 4 times 6 times 5 is 30. So that's going to be 120 minutes. Now this is a nice number because we know 120 minutes is actually just 2 hours. So we can actually just add 2 hours to 7:30, because the question is what time will they leave the station together. So 7:30 plus 2 hours is 9:30 a.m. That is your answer to this question. Okay, I'll see you in the next video.